Thank you. So let's talk about color. You all know this screen. This is the wallpaper of macOS Sequoia. And why does Apple choose to display this wallpaper? Well, as you can see, there's a lot of red in this green in this picture. And Apple has a technology that can allow it to display more green colors than on other computers. So if you are in a store and you see a Mac computer and another computer, you will see better color on the Mac computer. So you will buy the Mac computer just because they have a better color technology.
And there is a second fun fact about colors. Just as Britta had said earlier today, there will be a new law in Europe called the Accessibility Act. And this law will basically enforce more accessible features within our apps. And one of them concerns colors and contrast. Here you have an example with two buttons, one blue and one green, and both of them have a label written on it. It's in white, and your eyes can perfectly read what's written on the blue button, but not what's written on the green button. That can be explained through contrast, because the blue button has a darker shade, and you have a high contrast with the white label, but the green button is light. Wouldn't it be great to know directly through our code whether our colors are accessible or not, and not just rely through our subjective eyes? I'm Lucie, and this is Antoine, with two other people who have been sort of introduced earlier, Tico and another Antoine. We work at Thibierge apps on the quest of the perfect color for the past year, and today we want to show you the result of our research.
So to talk about this, we use this framework. So we are going to introduce you to the problems with the color, then our ID to fix all those problems, how do we validate this ID, and then how do we implement it. So first, let's take a closer look at our problems. And the first problem is that React Native is behind in terms of color technology. This graph is a representation of all the color that our eye is able to see. But it would be too costly to display all those colors on a monitor. So the standard was to display only a small fraction of those colors, and that was the sRGB standard. And this is the standard on pretty much most of the devices that you have around us today. And that's the standard that we have access to in React Native. In React Native, we don't have access to any other color outside of this spectrum. But there's a new standard, the pastry standard. And on all the iPhones since the iPhone 7, the screen is able to display pastry colors. But we can't display those colors in React Native. And there's more and more API that can give you access to those colors. For example, in Tailwind, in modern browsers like Google Chrome and Safari. And even in our archenemy, in Flutter. They have access to color in pastry, and we don't have access to color in pastry, so we should do something. And in the future, we will have another standard, the Reg 2020, with even more color. And there's Safari and Google Chrome on it. You can have APIs to access those colors, but you will probably not find any screen that can display those colors.
If we go back to our accessible problem, actually the color APIs we have in React Native contain a bug. Here we have our blue, and it can be expressed through different APIs, RGB, X, and HSL. If we take a closer look at what RGB is, you can see that we have 3 numbers, and each one of them represents a proportion of color. Now we compare it with our green button, and we have no way through this API to know which one has a lighter shade and if it's accessible or not. Then we have X. X is basically the same thing. You still have your proportion of color. It's just written differently in X API. And finally, you have HSL. HSL is a bit different, though. The first number corresponds to the hue, and in the common speech, it would be the color. So is it blue, is it green, is it violet, and so on. The second number corresponds to the saturation. So that means whether a color is pure or whether it leans towards gray. And the final number is actually what interests us. is the luminance, so the lightness of the color. Is it possible to know with HSL if our buttons are accessible or not? Not at all. As you can see, we have the exact same number for the lightness for both colors, even though we can see that the green button is lighter than the blue.
So now, how can we solve those two problems, the API problem and the color space problem? Well, for us, the reply was to use OkLab. OkLab is a color space invented by Björn Otterson, and it is described as a perceptual color space for image processing. So what does it mean? A perceptual color space means a color space that is representing what our eye is able to see, contrary to RGB, which represent proportion of color and how color will be displayed. And for image processing, it means that this color space is great to make computation on color. So for example, lightening or darkening a color. And finally, OkLab is also an API, so we can express color using OkLab. This is the example for the green color. We can express it using also OkLab. So how does OkLab help us to solve our P3 integration problem? Well, first, to understand that, let's take a look at this beautiful cube. This cube is a representation of all the colors that are present in sRGB. So as you can see, there's a red, a green, and a blue. And so that's our 3 dimension that allow us to represent all of the color. On a P3 device, you will have access to more color. So yeah, you will have access to more color. So as you can see, there's still a red, there's still a green, and there's still a blue. So with a simple transformation, we can still get a cube and so still use RGB to express color, but that won't be the same problem because the coordinate won't be the same. As you can see here, the reddest red in RGB is not as red as the reddest red in P3. So what would it look like if we implement this? So a developer will write a P3 color on a P3 device. So on this device, no problem. For the developer, he will just need to write the color like this with display P3 and the color using RGB. But then, what would happen on non-P3 device? Because there's still a lot of non-P3 device. So we need to make sure that we can still display a color. So to understand what color we'll be displaying, let's go back to our graph. So for this color, for example, that is both in sRGB and P3, that's pretty simple. The developer will write the color in P3 and will just make some computation to find the color equivalent in sRGB. So as you can see, the numbers are a bit different. And that's the case for about 50% of the color. For 50% of the P3 colors, they are also in sRGB. But what about the other 50%? For the other 50%, that's the tricky part. For this color, for example, we cannot find the direct color in sRGB. So we will need to use a gamut mapping algorithm, which is an algorithm that takes a color from P3 and is finding the best color available in sRGB. So what will happen? A developer writes display P3. Then we will compute the color into OkLab, because OkLab is a great color space to make computation on color. So with the gamut mapping, we try to find the best color available will work best with OkLab. And then we will use this algorithm, and we will find the best color available. So as you can see, the colors are a bit different, because in sRGB, you can't have access to the display P3 color.
The second question we need to ask is whether OkLab solves our accessibility problem. And the short answer is yes. Here you have both colors written in OKLCH API. It's basically OkLab, but in color coordinates. And you have the lightness included. And as you can see, you don't have the same number for the lightness. For the dark blue, you have a number that is below 50, while for the light green, you have a number that is over 50, which means that the label written on it should have the contrary. White has a lightness over 50, so we can read it on the blue button, but not on the green button. Now, what's the difference with HSL, you may ask? Here you have the difference. It's a graph with x-axis you have the U, and y-axis you have the lightness. And OkLab represents exactly what happened in your eyes, which means that depending on the U, we cannot see the same range of lightness. For instance, for a green, you would see a larger range of lightness compared to a light blue. However, HSL has decided to put everything in a square and therefore to pull those colors to fit that square. Now we put our colors blue and green on top of that. Again, we can see that the blue and green are on the same line for the HSL representation, which is not the case for OkLab representation. An example, a consequence of that, is the gradient. To compute a gradient, you will need to fix the lightness and to predict which U comes next. And because we have those colors that has been pulled to fit that square, it struggles to find what color comes next accurately. In case you cannot see it correctly on that gradient, maybe you can see it more here with OkLab gradient next to it. On the OkLab gradient, we have a result that is smooth, whereas on the HSL gradient, you have some colors that have been grouped together, especially in the red and blue areas. So all in all, OkLab allows us to first have P3 colors directly in your apps, but also to solve our accessibility problem.
So now, how do we make sure that implementing OkLab into React Native is the best thing that we can do? Well, the first question that we ask ourselves is, where should we implement it? And the reply was obviously reanimated. We thought about reanimated because it has an API called interpolate color. And with this API, we need to predict the next color. So OkLab would be a great fit in it. And so it could allow us to gather feedback from the community if we implement it in Reanimated. So we wrote an RFC, and we were just about to publish it when we had a call with Ricardo from the React Native core team. Ricardo will talk to us later. And he told us that at Meta, they have been trying to implement display P3 support to React Native, and they were lacking this gamut mapping algorithm to have the retrocompatibility with sRGB. So he was interested in us implementing OkLab into React Native. So we throw away to the garbage our RFC for Reanimated, and we prepared a new one for React Native. And for those of you who are impatient, a quick shout out to D4VD, who has implemented OkLab into Reanimated, so you will be able to play with that soon.
The second question is which algorithm we should use for the gamut mapping. A quick reminder, for a color that is in P3 but not in sRGB, you would need the gamut mapping algorithm to try to find the best available color in sRGB. Here you have an example of an image in OkLab, and everything that you see in black are actually colors that exist in P3 but not in sRGB. So you need your gamut mapping algorithm. But depending on the algorithm you choose, you can have really different results. And some of them can even be weird. So the first check we need to do is, does the algorithm produce good colors? Two algorithms seem to stand out, CLAMP and CSS4. Here you have the result for both of them on the red. Maybe you don't see a big difference in the audience. We have a second example here with a green. And again, there is not a tremendous difference between those colors, just slight differences. So we need to find what are the pros and cons for each solution. For CLAMP, it's clamped its values. It's just as its name says. So basically, it will be really performant because everything will be done in one go. However, we've noticed that sometimes it can have the worst possible results, but again, it's just slight differences, so it's still acceptable. On the other hand, we have CSS4, and this algorithm is already widely adopted since it is the one used on the web. So we do know that it's working perfectly fine. The question we need to answer now is it performant enough? If it is, we don't need clamp anymore. We can just focus on CSS4 algorithm.
So to know if it's performant, we run a benchmark on a Samsung J3. A Samsung J3 is the worst device you can have. It's a low-end device from 2017, and just opening Google Chrome, it takes about 10 seconds. So users are used to have a laggy experience with that. So we ran a benchmark on a code in JavaScript for colors that were in P3 but not in sRGB, so that were needing the gamut mapping algorithm. And we found out that to compute the best available color, it took about 800 microseconds for 99% of the color. So we found that this was pretty good results for such a laggy device. But then we ask ourselves, should we do it in C++? And we have a talk earlier today, so you are actually wondering, is the C++ really more performant than the JavaScript one? Yeah. Of course. The C++ algorithm is 20 times faster. This benchmark, we run it on Mac M2, but we are confident that also on another device, it will be more faster. Yeah. So with these results, we have that the CSS4 algorithm produces the best visual results, is performant enough, and is already widely adopted. So that's what we propose to implement in React Native. And that's what we propose to do in this RFC. And you can scan it and have a look at it. If you want to delve deeper into the colors, that's what we propose to implement in React Native.
The next step is the implementation. And we have a 3-step to implement it. The first step is what we have actually begun to do, is to convert P3 colors into sRGB. So it's basically using our gamut mapping algorithm. And this is an example taken from the web, but you will be able to use P3 colors through your APIs. The second step is to create a JavaScript API for OkLab. And again, an example taken from the web, but we would be able to use OkLab API directly in your code as a developer and to perform, to compute some algorithm or to modify your colors as you may wish. And the final step is to create a community package, and this time is directed towards libraries. So again, the example for reanimated. The goal here is to create the API for OkLab, but in C++, to make things faster.
And so we need to implement that, and soon it will be your turn to make better apps with better color. Thank you very much.
Awesome. Well, really cool work on this. It's great that it's in progress, and I think there's going to be some really cool results. It's one of those things where it's like, you kind of look at it and you're like, doesn't matter, but then when you actually see it in an app, I think it really makes a difference, and like the visuals just pop so much nicer. So I think it's going to be very well received, and there's going to be a lot nicer looking apps just from the subtleties of it. So great work on this. I didn't do a fun fact, as you might have realized, for them, because I didn't know how to do 2 fun facts before someone goes on stage. I tried to think of a good way, and it just didn't come up. So I'm gonna tell you a little bit about both of them, or the fun facts that I forced them to give me last night. So Lucie, you organize a Korean movie festival.
Yeah, each year.
On the Champs-Élysées.
Exactly. And this year is the 20th edition.
And again, you haven't organized it for 20 years yourself.
No,
Okay,
I'm not that old.
All right, fair enough.
It's been 4 years for me, and I quite enjoy it.
Nice.
Yeah.
Who, other than the French people in the room, okay, how many non-French people are there in the room?
Maybe with the club. That was a good idea, I think.
Cool. So the non-French people in the room, who's not been to the Champs-Élysées? Okay, you should definitely go to the Champs-Élysées. It's like an iconic.
There is a movie theater there. Great movie theater. You should go there definitely, especially in October.
Do you have like a discount code or something you're going to share with people afterwards?
Sorry.
Okay, fair enough. Cool. So yeah, if you're in Paris in October and you want to see some Korean movie festivals, hit up Lucie. Probably not for a discount code, but just
yeah.
And Antoine, you said you're dabbling these days in improv comedy.
Yeah. So that was actually the first time on stage that I had to say something intelligent. So,
can you say something unintelligent now, just to give us like a little taste? Please keep it PG. Please.
I don't know.
That's like the one thing you need to do for improv. Come up with it on the spot.
Actually, during the rehearsals, sometimes you would do improv some jokes. And I was just feeling so scared that you would do the same, but on stage, because I would not know how to react. I don't know how to do improv.
So that's how I feel.
No,
I feel so sad because all of my jokes, she just looked at it and just shrugged.
Did he do improv during the talk?
No,
okay,
that
good.
was fine.
All right, cool. You mentioned. So on your slides, you had some negative numbers for colors. What was that all about?
Yeah, they were on the slide where at the end we show what is the implementation, and you have an example with what happened in the web right now. And here you can see that you have P3 colors, and just next to it you have sRGB colors, but with negative colors, negative numbers. And in fact, those numbers are negative because they don't exist in sRGB, but only in P3. So that's how we know that we need to apply also our gamut mapping algorithm anyway, because that doesn't exist. And if it doesn't exist, it will just crash maybe. So
cool. Okay, that makes a lot of sense. Okay, fair enough. Someone's asked if Figma actually supports P3 colors, because they're wondering like, how would a designer represent a P3 color to you?
I think they handle it.
Yeah.
More and more devices like Adobe, for example, they handle it, of course.
They handle it P3.
Yeah, I had somebody from Theater Apps, because we also have a design team who, after our rehearsal, just sent me a screenshot and said, "Oh, now I understand why it's in Figma." So there is the option, yeah.
Okay, so that makes sense. Just wait for the day your design team comes and asks you for P3. Now you know how you can implement it when it's, actually implemented. How do you know in code if a device is P3 compatible or not? Is there a way? I guess maybe not in React Native APIs right now.
On iOS, it's simple. It's if it's above iPhone 7, it's compatible with P3. On Android, there's a new API, an Android API that tells us that. Of course, for the older version of Android, we can't see that, but then we will just assume it is not. I don't remember exactly the name, but is white gamut supported or something like that?
Okay, gotcha. Cool. Have you considered colorblind options in this proposal, and will the gamut algorithm function kind of work in a similar way for handling colorblindness?
So you mean the difference between colors between red and green, for instance?
I guess there's a bunch of different types of color blindness as well, as far as I'm aware. So I don't know if there's a one-shop algorithm for it. It might be a bit out of scope. I don't know the answer to that myself. So
I think the goal with OkLab was to make it, of course, more accessible. But for that kind of precision, I'm not sure if it can say, for if you have that color of blindness. Yeah, I mean, sometimes if it depends really on the color blindness, because we spoke a bit earlier at lunch with some people, and so there is some people who want more saturated colors, while other wants less saturated colors, and that would be possible with OkLab easily because it has that, but other than that, like the red and green. I don't know if it would be that easy to take into consideration.
Okay, fair enough. This is an interesting one. Is there an algorithm to do like the reverse of the gamut calculation? Like, can you go from sRGB to P3?
Yeah, of course, but it would be just very simple because all the color in sRGB are also in P3. So we just need to do the calculation the other way
it's
around.
a matrix multiplier.
But yeah, it's basically a matrix multiplier with a few nonlinear function, but nothing crazy.
I don't watch Monty Python, so someone's trying to make a joke here. I'll say it, and if it means anything to you guys, laugh. If it doesn't, we'll just move on.
Okay.
Since you told us what your names are and what your quest is, what is your favorite color? ? Monty Python. Sounds like a very British joke.
Wow.
I have no idea.
Whoever asked and you put your name as anonymous, just pretend like you didn't make the joke. Cool. Awesome. And on that note of Monty Python jokes, we'll wrap up the Q&A here. You folks are around, so if anyone has any more questions about this, feel free to chat with them at the coffee break or the after party. Big round of applause for Lucie and Antoine.